This week on QDL, we talked to Dan Sawyer, a mechanical engineer at NIST, as well as the person responsible for technical presentations at the Coordinate Metrology Society Conference, the CMSC, in Orlando. And what can you expect from this year's presentations at North America's only trade show for large volume 3D measurement? Well, you can find out in about 30 seconds. Welcome back to Quality Digest Live. QDL is your weekly look at who and what is making news in the world of quality. I'm Dr. Sharm, Editor-in-Chief of Quality Digest. Well, as a lot of you know, every year the Coordinate Metrology Society Conference, or the CMSC, is held somewhere in the United States. And this year it's going to be July 22nd through 26th at the Renaissance Orlando at SeaWorld. And if you are involved in any way with large volume 3D measurement, then this really is the show for you. This is kind of the one place that you can go in the United States every year where you can really see all the various types of equipment and technologies that are used in large volume 3D scanning. There is also small volume too, but it's probably its main focus is on large volume. One of the most interesting aspects of the show, I think, are the variety of technical presentations. They are always really interesting. They are non-salesy, and most important, they're relevant. They're relevant to your industry and the kind of problems that you're trying to solve. And with us here today is Dan Sawyer, a mechanical engineer at NIST, as well as the person responsible for technical presentations at this year's CMSC. Dan, thanks for joining us today.
Thank you for having me, Dirk.
Hey, no problem. So before we get going a little bit, why don't you tell us a little bit about what you do at NIST and kind of what your function is and what your department does there.
Okay, so as you said earlier, I'm a mechanical engineer. I am the group leader of the Dimensional Metrology Group. Been at NIST for over 25 years, so sometimes I feel like a newbie. That's just simply not true anymore. So my group has two primary functions. We provide measurements for folks who need really high accuracy calibrations on sophisticated measuring instruments, like laser trackers, articulating arms. Most of those measurements and calibrations are done just for the manufacturers that are doing proof of concepts for new instruments. We do standardization along with that effort. We develop documentary standards that provide people with spec sheets that help them make informed investments in equipment. So instead of trying to compare two instruments, two laser trackers blindly, you can actually go to a national and international standard that provides a spec sheet that the manufacturers put their specifications in there so you can make informed decisions. That's a significant role of NIST's Dimensional Metrology Group.
So if is this the same? Would that department be the same that would be creating, how do I want to say this, calibration procedures for 3D, different types of 3D measurement technologies, in the same way that NIST makes measurement standards like gauge block standards, that sort of stuff. Is this also true for what you're doing with 3D?
Yeah, so these calibration procedures, you can call them calibration procedures. We call them performance evaluations. They go into the documentary standards. Most of the technical content of those particular measurements comes from the National Measurement Laboratory. So we look at a new technology. Let's take, for instance, laser trackers. We look at the technology and we say, okay, where are all the error sources coming from? They have to do with lack of squareness between the axes. They have to do with encoder axes that are not coincident. We look at these and we see how these propagate into errors in the instrument. We get a whole collection of all these error sources, and then we devise tests that are optimized to be able to be run efficiently in a laboratory, but that capture all of those error sources. And frequently, companies that provide calibration services use these procedures in the standard as part of their calibration procedures. And that's a good thing, because those procedures are very thorough. They're based on really sound, defensible technical evaluation of the instrument's error sources and careful measurements and evaluation of test procedures to make sure nothing is missed.
Okay. Okay. So let's switch over here to, now that we kind of know what kind of your technical background and where you're coming from, I want you to tell us a little bit about, I believe there's 21 technical papers that are going to be presented at the CMSC conference this year. Can you give us just kind of a little insight what people can expect from those?
Yeah, well, they're all over the board. I'm really excited about it this year. We have an interesting paper from Joshua Montanano from Los Alamos National Laboratory. One of the things I really like about this particular conference is that you get to see best practices from some really smart people. You don't always have time to try out all these things in your lab and learn, but we can kind of collectively, by discussing things together, put together a body of understanding that helps all of us create value for the organizations we work for. So Josh was actually going to be presenting an effort that of some experiments he ran in his laboratory to see how well you can actually measure density using laser scanners attached to an articulating arm. So density is defined here as the mass per unit volume. He's actually used a laser scanner to measure the volume by getting lots of data points on a surface. He's independently measured mass, and now he's comparing that to an independent measurement of density using other methods. It's kind of a backwards way the back end side way of evaluating how well laser line scanners can measure volume. Really interesting paper. There's another paper I'm really excited about from Scott Porta, and it's being presented by Faro, and it's about high-end catamaran design. So these boats now are moving so fast that it's not just the hydrodynamics that are important, right? The boat, part of the hull spends time in the water, but at 100 miles an hour, there's a lot of that hull that's outside of the water. And because of the speed, the aerodynamics are becoming more important. So Scott is going to be talking about measurement of the catamaran hulls using large-scale coordinate measuring instruments to get a better estimate of the shape, so they can do sophisticated computational fluid dynamics calculations. It's going to be really interesting. That's a different kind of paper and an application I don't think we've ever had at the CMS before.
Yeah, that's interesting. I mean, and I was going to say, it kind of leads into my next question, kind of when I've been seeing these papers before, the type of information is really varied. I mean, it can be, very technical in terms of, as you mentioned, kind of just, can you determine density from two different types of measurements, mass and then volume, but then also it gets into problem solving, and I see a lot of that, and how you use different types of equipment, sometimes even competing equipment. If you look at who attends the CMSC, they might use a product from one manufacturer and a product from another manufacturer, use them together to solve some particular type of problem. And I thought that was always really interesting within the CMSC presentations. It's all about problem solving, right?
Yeah, it really is. And like you said, this is the only conference of this type in the U.S. So this is the one unique instance where you get all these folks who are involved in the same industry to say, boy, what have you learned? So I'll tell you, we don't just simply put out a call for papers. We call people and ask them for papers. We know kinds of things that folks are working on. Folks on the executive committee are members of companies. They're in education. They're in government laboratories. So we go out there and really recruit people to present papers on topics that are important. And so I think that it really does a really good job of providing valued information that really advances this profession in ways that's needed, and with the variety of complex measurement tasks that we're being asked to solve by our employers every day.
Yeah, and I would say, you're talking about information that they can glean from, obviously from the wide variety of papers that are presented, but also talk a little bit about the kind of training that attendees can get when they go to a CMSC. I understand there's actually also a training component.
There is a training component. There's now a lot more activity associated with providing training for coordinate measuring machine operators. One of the questions that business owners ask themselves is, what is a qualified operator? I mean, there's no bar exam for metrologists that tell them they are proficient, tells a potential employer that this person is proficient. There's no qualification exam like you might have for engineering training. So CMS has really stepped in to kind of start putting together these training programs for folks who are using articulating arms, laser trackers, coordinate measuring machines, so that, number one, people are learning how to use these instruments correctly to add greater value, but number two, to help employers get the information they need to hire qualified folks. And so I'm really proud of that, of the educational component, because I think that just helps our society altogether. It is a much needed advancement in our profession.
Well, I'm glad you actually kind of led me right into my next question here. You're talking really kind of about workforce development and how we grow that. So how did you, give us kind of your personal story. How did you get involved working at NIST with a career in measurement sciences? Was this something that you pursued right out of high school, or how'd you get into this?
I was crazy enough to believe I was going to be a professional football player. All of 5'7" and 180 pounds at the time, soaking wet. It wasn't like. But I went to school on a partial scholarship at a football school, and I got a business degree. And when I got out, I said, "Boy, this really isn't what I wanted to do. I've always had enjoyment of technical, learning technical things." So I went and got a bachelor's degree started a bachelor's degree in mechanical engineering, and I co-opted NIST as an engineering aide while I was going through school. I ended up in the metrology group because there was an opportunity there. They were looking for a technical person who had a mechanics background. And as things, frequently work out, you go, "Boy, I've never heard of this before." Yeah. And you start working in that area and you find that you may have a love. So when I learned of metrology as a co-op here at NIST, I really took to it. The care in which measurements have to be performed to really add in quality and ensure quality of products was something that I really enjoyed being involved in. And I think the metrologists that you interact with at the CMSC, you'll find people that feel a similar way. Oftentimes we feel a little isolated. We have technical backgrounds, and lots of folks want to work on dynamic environments that are not related to performing very careful measurements, doing very precisely, checking yourself to ensure that when you push some product down the line, you've made sure that quality has been assured through the production cycle. So it really was by chance. I've had opportunities to leave, and I've never been close to being coaxed away from this organization.
Yeah, and I think it's interesting. It's funny for something that pretty much nobody has heard of, metrology. It's something right. It's something that affects every single aspect. Everything we do, everything we relate to, everything's been measured or has to be measured at some point. So it's this critical part of industry, from low-tech parts to high-tech parts, and yet it's an industry that nobody knows anything about.
Yeah, there's just tens of thousands of men and women behind the scenes whose job it is to set up tooling and making sure it's accurately and precisely set up. That requires measurement, careful measurement, and to check parts to ensure they're made to the proper specification, because that ensures the quality of fit and function. They're doing their job, and that they're doing it better and better if you look at the life cycle of manufactured goods. It's getting just ridiculous at some point now. I wanted my TV to blow up years ago so I could get the latest technology, but they make things so good now that they last well beyond what would be state of the art, so that you end up having something that works, and you really want the next generation TV or a new car. I can't get my car to blow up so I can buy a new truck. Right. It won't stop running because quality is such a part of manufacturing, and we understand, dimensions so well that things really run quite well for long periods of time.
Yeah, I keep giving my cars away at 350,000 miles. It's like, I want to drive something new now, and this one's still running, so I give it to a friend or some friend's son or daughter who needs a car, because it's like, after 10 years, I'm tired of driving this thing, and it's got 350,000 miles on it.
If that's your problem, blame us.
Blame you. Well, before we go, I want you to be able to make a little bit of a plug for NIST. I don't think people know. I think, again, this is one of those things a lot of people don't know, that the National Institute for Standards and Technology, which is a non-regulatory body of the U.S. Department of Commerce, they do a lot to support American manufacturing. So why don't you just kind of tell us in a nutshell, how does NIST do that? How is NIST supporting U.S. manufacturing?
Well, there's lots of efforts, but we talk about U.S. manufacturing, we talk about the whole of U.S. manufacturing. My group, which is the dimensional group, supports primarily the folks that make parts that get assembled all over the world. We have lots of measurements here that are performed for the electronics industry, for the lighting industry. And so what we do is we kind of provide the roads that help manufacturers in this industry build better and new products. So you want to build a better measuring instrument, you're going to need access to high quality standards so you can test proof of concept. If you want to sell your product and you want people to have enough information to make informed investments, documentary standards provides ways for people to have a standard level playing field in which to compete, so that people can more easily engage in commerce and buy and sell goods and products. And in the process of participating in those two activities, sometimes we invent things. So very few people realize that laser trackers, which are really the workhorse for large-scale metrology, were actually invented in NIST.
Wow.
Not to make measurements for private industry, but it was part of an effort to develop an instrument to do an evaluation of CMMs and machine tools. But it had such applicability that it was licensed and commercialized. So it's really standards, electrical, dimensional, fluid, for all kinds of documentary standards, all kinds of very high-end precision measurements that are needed by the most advanced manufacturing companies to help them make those commercial products that you buy, sell, and use every single day.
And I think we should point out also that NIST actually has a track for doing what you're talking about, so that things that are invented or are developed within NIST, that there is a pathway for commercializing those things, that it's not all just academic stuff and isn't this interesting, but there's, how can we now that this is a cool thing, is there some way we can get that out into the commercial market? And you guys have a path for that.
Yeah, we're very few people realize that we're not in the national the NRC. We're actually a part of DOC, the Department of Commerce.
Okay.
So our job really is to engage in activities that help enable commerce. So our effort is not to do basic research and catalog knowledge, but rather to engage in those activities that help you do your job better, that promotes commerce and equity and fair trade.
Yep.
So we're not university professors. We are really folks who are looking to find out, what are your problems? What limitations do you have? What standards do you need to buy, sell, and to make new products?
Perfect. Well, Dan, I think we'll leave it with that. Dan Sawyer, he's a mechanical engineer at NIST. And he's also in charge of technical presentations at this year's CMSC in Orlando. So, Dan, thanks for joining us today. Appreciate it.
Thanks for making it easy, Derek.
All right, I'll see you in a few weeks, actually.
Okay, take care.
Okay, take care. Okay, well, that is all the time we have for today. And as usual, if there is someone you would like to see on the show or some topic you would like us to cover, send those ideas to us at qdl@qualitydigest.com, and we will try our very best to cover those topics on the show. Thanks for joining us today. We will see you next week on QDL. So long.